this session, and we are going to answer some questions. So we might have a very short lecture today, but let's see how things go. Let me just switch to my handout. Okay, what was the problem? The problem was graph what? Graph, what was it? Y is equal to sine of X, was it? Was that the question?
Yep.
Yeah. So of course, this is in 3D. All right, in 3D, we don't call this a sinusoidal curve. We call this a cylindrical surface. Okay, I just remembered something. Remember that mock quiz I put on Blackboard? I wanted you guys to kind of take it as if it was a quiz. So, you know, I decided whoever did it, he or she got 5 points just for doing it. And some of you did it, but you did the questions on one page. That wasn't the instruction of the quiz. It was like, can you answer the questions on 2 separate pages and form a single file? I think some of us misunderstood the instruction. So please redo it. I think it expires like tomorrow night at midnight. So if you haven't done it correctly, please do it correctly. Remember, you're supposed to send me 2 pages as a single file in PDF. And if you did it on a piece of paper, so scan 2 pieces of papers, you know, answering each question on separate pages, and then scan it and PDF it and upload it to the Blackboard under the mock quiz. You can also upload your solutions to review problems for 10 points extra credit under the review problems on Blackboard. So I will take a look at it. If it is complete, you get 10 points. If it is not, then you will be graded accordingly, yes? So bear with me. So I thought maybe I should bring that up to your attention. Let me see if we have any, but we can still, yes, you can still, yes, of course you can still resubmit it. That's what I said. I extended the deadline to tomorrow midnight. So please do it correctly. Don't write both answers on one piece of paper and upload it. So that was not the purpose of that assignment. All right, so let's get right to it. So here we are. So this is our three-dimensional coordinate system. So that's Z, that's Y, that's X. So let's graph this on the floor first. So here's pi over 2, here's what? Pi, here's 3 pi over 2, and here is what? 2 pi. Okay, so at x equals, let's say pi over 2, y, at x equals 0, y is 0. Pi over 2, y is what? 1. Pi, 0. 3 pi over 2, y is negative 1. And 2 pi is 0. Do you all see it? So on the floor, you and I, like from trig classes, we know the graph looks like this. So it's a curve. So on the floor, it's a curve, right? It's one-dimensional object. However, when you say y is equal to x, that doesn't mean z is 0. That just means z goes from negative infinity to infinity. Is that right? So therefore, you have to extend this along the z-axis like so. Is that right? Like so. And you kind of go like, and lo and behold, you get a surface. Do you all see it? Do you see it? It's kind of like a wavy surface in a space. Do you see it? There you go. There. So now this is not a curve anymore, is it? It's a surface. As a matter of fact, it's called cylindrical surfaces. Anytime one of the variables is missing from your equation, chances are you have what? A cylindrical surface. Do you all see it? Also, if the what equation is linear, you and I, we both know that what the graph in what in three-dimensional space would be, well, this is kind of a special cylindrical surface, which we call a plane. So basically, this is how that guy looks like. On the floor is a 45 degrees line. But once again, notice z is missing. That means z goes from negative infinity to infinity. So the graph is not a line anymore. It's a plane. Do you see it? It's attached to the z-axis, and it makes a 45 degrees angle with the floor. So this is x-axis, that's y-axis, that's z-axis. So plane happens to be what? The simplest surface you can get your hands on. You all see it? As a matter of fact, you can just move, you know, go on with other graphs, like let's say e to the power of x. Okay, what is it? On the floor, e to the power of x looks like this, doesn't it? So it hits the y-axis at 0, 1, and it kind of what gets close asymptotically to the negative what x-axis. So how does this guy look like in 3 dimensions? Well, it's not going to be a curve anymore. It's going to be a surface. As a matter of fact, we also call this cylindrical surface. Cylindrical surface. Okay. So what do we do? At x equals 0, y is 1. At x equals 1, y is what? E, which is like 2 point something. At x equals, let's say, 1/2, so that would be like still positive. So how would it look like? Well, it's going to go through this point, and it's going to get close to what? Asymptotically, what? How is that going to look like? It's going to kind of go, is this, let me see now, what is e to the power of, let's say, 1/2. So that's e to the power of 0.5, which is 1.6, somewhere out here, that's fine. But what about the negative values? Like, let's say, e to the power of, say, negative 0.5, so 0.6. So when this guy is negative 1/2, you get 0.6. So is it gonna look like something like, how is it gonna look like? So it's gonna get close to something like this. Is that right? Am I doing this right? Is that right, guys?
Yeah, because it's
Yeah.
XY plane.
Yeah. So
And
it's
then just extend it up to the
extend it
z-axis.
up, yeah, exactly, and then extend it up, and lo and behold, you have kind of like, you see where this is going, right? Kind of like, yeah, there you go. Yeah. So notice it's a surface, right? It's no longer a curve. Surface is two-dimensional object which lives in what? Three-dimensional space. Curve, it could be what? It's one-dimensional object, but it could live in two-dimensional what? Three-dimensional space. As a matter of fact, if you notice all those vector value functions, the graph was a curve, which was in what? In 3 dimensions. So that's why we called it space curve. Do you see it? I hope that answers your question. Ahmed, so there you have it. Any other question? I have the handout in front of me. So let's go over these problems one at a time.
Professor, I have a quick question.
Yes, please.
It's about the midterm. I know you're saying that we can just like look at the problems and then write our like work and like the number on just a blank piece of paper and scan that. So my question is, does it matter if we use like graph paper, binder paper, printer paper? Are any of those okay, or do you have?
Everything is okay, but try to keep the pages as minimum as possible. So if you won't like upload like 10, 12 pages. What happened is the following. I already made the test, and I have provided some space between the problems. Hopefully you'll be able to what? Use those spaces between the problems and squeeze your solution in between. However, if you ran out of a space, let's say you write big, so you couldn't squeeze the solution between two problems, then you may use the scratch papers. But I have left some spaces between the problems, depending how lengthy the problem is, so you guys can show your work on the exam. Do you see it? So that would be the ideal case for those of us who have access to printer, so you can print the test and do it and write your solution on the test and then scan it and upload it back on the Blackboard. For those of us don't have the access, don't have access to printer, so we may have to what? Just write our solutions on piece of paper and scan those. But can we use other papers? You betcha. Whatever it takes for you to do the problem, or you are comfortable with, I have absolutely no restriction on how many pages. But as I said, just to make my job easier, keep the number of pages as minimum as possible, so I don't have to look at like 10 pages for limited number of problems. The problems are kind of close to this, but it's not exactly the same. And there are one problem which you may or may not have seen it, I don't know. But that one problem is decided by the department. So all the Math 2140 people are gonna have that one common problem. So we're gonna compare our results and see how the class is performing. So I don't guarantee on that one. I can't tell you what it is, but there is one problem which was given to me by the department. So be outside of the range of these review problems. But I'm not sure if we have covered that on my lectures. If we have, more power to you. So that shows you that my class has seen it all. So that makes me look good. But if you haven't seen it, give it a try and don't give up. Whatever you do on Thursday, don't leave any problem blank. Just put whatever comes to your mind for partial credit. Yes? Also, the exam starts sharply at 5. Is that right? And it finishes sharply at 7. Do I really need 2 hours to finish the test? Not really. Some of them are straightforward computation. However, the only thing I ask you guys kindly is please do not Google the answers, all right? Do not what? Copy a foreign solution on the test. In other words, don't come up with a solution which I haven't shown you. Make sure your solutions are within the framework of the class. Because sometimes people might Google the solution and get it from all these sites, which I don't want to mention the names, but you guys know where they are. And lo and behold, it's like, yeah, that's the correct answer, but we didn't do it this way. I mean, where did you pull this from? So I kindly ask you that keep the integrity of the test as much as possible and make sure the work is yours, not someone else's. Keep in mind that defeats the purpose of taking this class. Remember, this class is prerequisite for most of the engineering classes. So you really want to learn this class, not to, take a shortcut or cut the corners. So it's up to you, but keep it as honest as possible. As a matter of fact, on the very first page, I have a pledge form, which you will see it and you will read it and sign it. Basically, it says, I'm taking the test on my own. I haven't got any help. And this is my work. And I sign it because I acknowledge the work is authentic. It's not someone else's work. So please keep the solutions as honest as possible. That's why I put very simple questions. I mean, you guys can zap through the test. There is no need to Google it. And I'm sure you all will get a high score because there are no tricky problems on the test. It's basically what we have done so far. So we will see. But I have a good feeling we're going to have an extremely high average on the very first test. So let's just hope and pray to God that's the case. Do we have any comments or anything? So only one problem. Yeah, as I said, that one problem might be your luck. I might have mentioned it in the class. So I don't remember, but you guys have your notes. You know what I have done, what I haven't done. So, and this saga, this procedure will continue for final exam too. So every class has a coordinator. So the coordinator dictates what we should put on the exam, what we shouldn't. And at this point, they want us to put one problem which will appear on all the Math 2140 exam number 1. So please don't try to check with your friends and see what the questions are. So keep it as honest as possible. I will be more than happy to answer any question you have tonight, so there will be no need to, cut corners on Thursday night. So let's get back to the review problems. I was going to ask you, let's just go over these guys 5 at a time. Problems 1 through 5, any question?
Someone said 3B.
3B, yeah, please inform me what's on the chat. I can't go back and forth, so 3B.
Yeah, no problem. I'll just check.
Sure, thank you so much. I really appreciate 3B. What was 3B? 3B, 2x plus 3y is equal to 6. Because this is a linear equation in 2 variables, but we're trying to graph this in R3, you and I, we know the graph is a plane. Okay? So on the x and y axis, that means on the floor, you and I, we both know this guy hits the y axis at 2. Is that right? X-axis at 3, there. Okay, so this is how the graph looks like. So it's a line on the floor. But this is not on the floor. This is like a surface. As a matter of fact, it's called plane. So what you do, you kind of go over your 3-dimensional axis like so. Okay, so the x-axis is 3, so this would be 3, 0, 0. Y-axis is 2, so that would be like what? 0, 2, 0. Connect these two guys, but remember z is missing, so that means z goes from negative infinity to infinity. So therefore, extend this along the what? Z-axis, and lo and behold, you got your what? Your plane. Do you see why am I making these portion of the axis dotted line? You guys see what's the logic for making it dotted line? Does anyone see it?
Perspective.
Sorry?
Perspective or projection.
Perspective and protection, and also this is behind the scene. I don't see it. You see what I'm saying? The plane is blocking this. So whenever something is behind the surface, we show it with dotted line. So pretend this is like a page of your note is blocking the what? Coordinate axis, so you can't see it. Incidentally, that doesn't mean the graph stops here, right? The graph kind of goes on forever, right? Like this, see that? See that? I'm just showing you what? Snapshot of the picture. Do you see it? As a matter of fact, I'm showing you the first, what? Octant view of the what? Of the graph, okay? Which happens to be called a plane. So, just to give you a heads up, we're gonna have a few problems on graphs, which you will be asked to graph and also mention the name of the graph. What is it called? All right, so make sure you distinguish plane from cylindrical, surface from ellipsoid, from elliptic, paraboloid. Make sure you identify these pictures one from the other one, and make sure you spell them correctly, because in class I would have people pronounce it so I can see if they are pronouncing it correctly. But make sure you are okay. How many questions? Oh, enough to keep you busy for 2 hours. As I said, I will strongly doubt it that you're going to spend 2 hours on the test. I'll be shocked. But then remember, problems are taken from chapter 12 and 13. So that was 3B. Any question from on 1 through 5?
2B.
2B. What's 2B? This right here? That would be like take the cross product and whatever the vector you get, dot it with what? A, so the answer is going to be a scalar, correct? So is that right?
Yeah, because the answer would still be a vector because a scalar times a vector is still a vector.
No, the answer is not as, yeah, the answer is a scalar because dot product never gives you a vector. This guy will give you a vector. Let's call that vector, oh my God, D. But A dot D is a scalar.
Oh.
So the answer is going to be a number. If that's what you got, you are right. Is that what you have?
Yeah, I have a scalar on that one.
Oh, great, great. Yeah. Do what's inside the parentheses, which is a vector, cross product. You know how to take the cross product. Then dot it with vector A, make sure you get a number. Okay, we good? Problems 1 through 5, we good? All right. How about 6 through 10? Problems 6 through 10.
6, actually.
6, actually? I think we have done that too.
I think there's a student asking a question.
Yeah? What's that?
Professor.
Yes.
Okay. On the one we just covered,
Uh-huh.
it's the dot product of A with the cross product of B and C. I noticed on the like properties, can't you do the cross product of A and B and then just do the dot of C?
You could, but why memorize a property if you can just see what you're supposed to do? Just like, you know, algebra classes, usually we take care of what's inside the parentheses, right?
The only reason is because they had us do B
but
first.
right, it should come up the same. However, I just do it just the way I see it. You know, I see a cross product inside the parentheses. I do that first and then take the dot product. Otherwise, you have to use the properties. However, at the end of the day, you and I, we should come up with the same answer, no?
All right, cool.
Sure. So what was it? We already did 6, did we not? When you kind of set these guys equal to 0, but let me just kind of give you a hint on that. So perhaps you guys have forgotten. So the parametric equation of the first line is given to us this way. Is that right? So that's L1 and L2 is what? X is equal to 1. No, that's not 1. T plus 3 and Y is equal to what? 3t minus 4, correct? And z is equal to negative 7t plus 2. First of all, how do I know if these lines are parallel or not? How do I examine the parallelity of these two lines? Can you tell how? Can you tell me what's the direction of this line?
1, negative 2, 1.
1, negative 2, you mean negative 3. Is that right?
No. Oh, yeah, that is negative 3.
Right, remember?
Sorry, the T looks like a plus.
Yeah.
That's why I got confused.
Yeah, my bad. So the coefficients of T are the components of the vector, which is what? Parallel to the line. And similarly, here you get 1, 3, negative 7. because 1 is not scalar multiple of 2, so we know what lines are not parallel. Just because they are not parallel, that doesn't necessarily mean they cross. Okay, so like in on the floor, when you had two lines, they were, they weren't parallel. Either they crossed or they were sitting on top of each other. Here, either they will cross or they will be skewed, meaning each line will be on a different plane. They won't be on the same plane, because if they are on the same plane, chances are they might cross. So how do we do this? Well, if they're gonna cross, they can't possibly cross for the same parameter. Remember I did a problem about two aircrafts flying in the sky, and the idea was, do they ever cross each other's path? But that doesn't mean do they ever collide. That just means, do they ever cross a common point, but not necessarily at the same time, at different times. So what I will do, call these ones T1s, call these guys T2s. So if you don't mind, let me just rewrite this so you guys can see clearly what I got. I got 2 plus T1, y is equal to 3 minus 2T1, z is equal to 1 minus 3T1. That's line number 1. Line number 2 is what? X is equal to 3 plus T2. Y is equal to what? What is that? Negative 4 plus 3T2. And Z is equal to 2 minus 7T2. So for these guys to what? To cross each other's path at not necessarily the same time. So what I'm going to do, I'm going to set what? The x components equal, like so, and see if I can solve this system of linear equation for what? For T1 and T2. Guess what? You got 3 equations, but only 2 unknowns. What are the possible solutions? When you have more equations than your unknowns, possible solutions, either you have a unique solution or you have absolutely no solution. There is no such thing as infinite many solutions. So when does that happen? When you have more equations than your unknowns, correct? As a matter of fact, that's the topic of this week's in Math 2240, system of linear equations. Of course, we don't do these by algebra method. We do it by something called matrices. So those are the possible solutions where what? When the number of equation exceeds the unknowns. So what you could do, take the first equation, T1 minus T2 is equal to 1, and the second equation, which is minus 2T1 plus 4T2 is equal to negative 3, we get about equation number 3 for now. Go ahead and pretend this is an algebra class and solve this for T1 and T2. Well, as you know, I'm going to multiply the top by, let's say, 2. So that's 2T1 minus 2T2 is equal to 2, minus 2T1 plus 4T2 is equal to negative 3. These guys cancel. 2T2 is equal to negative 1. So T2 is negative 1/2. Go back to either equation 1 and 2 and find T1. T1 is equal to 1 plus T2. So that would be 1 minus 1/2, which is also 1/2. However, before we all get excited and say, wow, they do intersect, there it is. Don't forget, we have to check equation number 3. In other words, the values you got for T1 and T2, do they also satisfy equation number 3? Well, let's see now. 1 minus 3T1. Is that the same as 2 minus 7, what? Where am I? T2. Okay, let's see. Back up. What was T1? T1 was plus 1/2, was it? And what was T2? Excuse me?
On number 2, I think it's negative 4 plus 3 plus 3t, no?
Which one?
Number 2.
Negative,
Right there, yeah, where your pen is.
right
Number
here.
2.
Negative
The right
2,
one.
this
Is
right
it
here.
negative 4 plus 3t?
Let me see. This is number 2. Oh my God.
Yeah?
Jesus. You mean negative 4 plus 3, 2?
Yeah.
Let me see. Okay. Sorry about that. Oh my goodness. Okay. So, sorry. Thank you. Thank you so much. I really appreciate, huh?
Yeah.
2 plus T1 is equal to 3 plus T2, but you saw where I was going with that. Thank you for catching me on that one. And this is 1 minus 3T1 is equal to 2 minus 7T2. Do I have it correct now? I apologize and sorry about that. So where were we? T1 minus T2 is equal to 1 minus 2T1 minus 3T2 is equal to negative 7. Am I doing this right? That's equation 1 and 2 in a standard form, correct? So now, if you don't mind, I'm going to multiply the top equation by 2. So these guys will cancel. So I get negative 5. T2 equals, say what? Negative, what, 5? So T2 is equal to 1. Thank you, even better. So if that's the case, T1 is equal to 1 plus T2. So that will be 1 plus 1, which is 2, correct? Now, what about equation number 3? Well, 1 minus, well, let's see now, negative 3T1 plus 7T2 is equal to what? 1. So negative 3, what? 2 plus 7 times 1. Does that add up to 1? That's negative 6 plus 7. It sure does. So therefore, they do intersect, correct? What would be the point of intersection? How would I find it? Because remember, these two values of t satisfied all 3 equations, correct? So what would be, where would I get the point of intersection? So obviously they intersect because I have a unique solution. Remember, the possibilities where either you get a unique solution or no solution. So in my case, I have a unique solution. So that means they do intersect. So they intersect. So how would I find the point of intersection? Any idea? Yes. I can hear you. I need to find point of intersection. Anyone? Nothing?
Do you plug in t equals 1 to the original equation?
Either you plug in T1 for this guy or plug in T2 for this one. It doesn't matter. So either of these guys will give you the point of intersection. If you go with this, replace the T2s with, what is it, with 1. If you go with this, replace the T1s with 2. It gives you the same point of intersection. So if you don't mind, I'm going to take the first equation, which was this guy. Is that right? Make sure I do this correctly. So what was my T1 now? Was 2, so this would be like 4. What is this? Negative 4 and 3 is negative 1. Negative 6 and 1 is negative 5. So ladies and gentlemen, this is your point of intersection. Do we all see it? You could also, what, go back to parametric equation of L2 and replace T2s with 1 and get the same point. So that would be the point of intersection. However, if you did all this and your solution did not satisfy equation number 3, so that means they don't intersect. Well, they are not parallel, they don't intersect, they must be skewed. What does that mean? That means they are what? They are on different planes. You know what I mean by skewed, don't you? That's like the corner of the room. This is like the 2 walls, and this is like the floor. one line is right here, the other line might be right here. So those are skewed. They cannot be on the same plane. Otherwise, there's a possibility they might cross. Do you see it? Does that make sense? I apologize for the little detour I made. So, yeah. But I think we got it. So 6 through 10 clear? 6 through 10 clear? How about 10 through 16? Problems 10, or I should say 11 through 16. If you have any question, please let me know.
Can we go over to number 12?
Number 12, what is it? That looks like a cone, doesn't it? And looks like it's gonna open along the x-axis. So if I had to guess the answer, I would say that kind of sort of looks like this. Do you remember I had a handout at some point? And remember I had quadric surfaces. Do you remember that handout? But unfortunately, I don't have it accessible now. But I would say number, what was it, 13 is x squared equals y squared plus z squared. So what happens if z is equal to 0 on xy plane, you get x equals plus or minus y. On what? On xz plane, you get x equals plus or minus z, okay? And on yz plane, you get what? This guy, which is a point. So these are intersecting lines on what? XY plane, XZ plane, and you have a point. So the cone is going to go through the origin, all right? Because X is on one side, so what's going to happen? You're going to get what? These intersecting lines, okay? At some point, let's say, I don't know, let's say this is y is equal to 1, and let's say y is equal to -1, excuse me. Let me just do this one more time. So there it is. So you have two intersecting lines. Remember, these are intersecting lines passing through the origin, correct? So it's going to be, how is it going to be like, let's say, oh God, let's say something like this and something like this. Okay. Remember, you cannot plot points. It doesn't make sense. So something like this. Because X is on one side, you know that what cone is going to what? Kind of open along the what? X-axis. So at some point, let's say, oh, I don't know, X is equal to -1 and X is equal to 1. I wonder what would be the intersection of X equals -1 with this surface. If X is equal to -1, I get 1 is equal to y squared plus z squared. So I have a circle in YZ plane. On the other hand, if X is equal to 1, I get the same equation, correct? So I get circles. So these are the circles, which they kind of don't look like a circle, but in 3 dimension, they are kind of like a circle. Do you see it? So there you have it. Okay, right? So it's a cone which opens along the what? X-axis. Do you see it? The one I did, it opened along the z-axis because I had z squared equals x squared plus y squared. However, this is x squared equals y squared plus z squared, so it still is a cone, but it opens along the x-axis. Let me ask you something. If I had x equal y squared plus z squared, what would you say the graph of this guy is? You see what I did? I took the power of x out. I made it x to the first. How would the graph of this guy look like? What is it called and how would it look like? Does anyone guess the answer? Oh, we have it. Let me see. is that one called elliptic paraboloid. Gerald, yes. And because x is on one side, so the elliptic paraboloid, by the way, because the denominators match, you see the denominators are invisible one, so we call this circular paraboloid, but you are right, thank you, very close, yes, you are so right. So the paraboloid, you know, the bowl kind of shape is going to open along the what? X-axis. There. There. Do you see it? So this is the full view, right? Full view. If you want to what? Show first octant view, you could do this. So like here's the paraboloid, and now close it up like this. There. So this would be like first octant view. You know what I mean by first octant view, don't you? That's like 1/8 of the surface. Because remember, coordinate system divides the space into 8 octants. In the first octant, x and y and z are positive. You see it? So that's the first octant view of this guy. By the way, how did you know here is a circle? Because right now, if you set each of these guys equal to 0, can you see I'm getting parabolas? So these are those parabolas right there. However, how do you know it's a circle here? Well, let's say at x equals 1, you get y squared plus z squared is equal to 1, so it's a circle. Do you see it? So that's how that guy looks like. Are we good with that problem? Do you all see it? Let me see, what do we have? All right, great. I'm so glad that you saw it. Okay, anything else? Yes?
I have a question on a part of number 11.
Part of number 11. The distance between a point and a plane. Okay, which part?
So I get that. So you have the plane, and then you use the normal vector of the plane, and then you pick a point on the plane, and then you draw lines, and you use the dot product. My question is, when you're making the line segment, like the vector for the line segment, does it matter which direction you go, whether it's from the plane to the point or from the point to the plane?
No, it doesn't. However, technically, in distance problems, what happens if you take it the other direction, then your answer might come up negative. That's why at the end of the problem, we have to take the absolute value of the dot product, because as you know, the dot product possibly might give you a negative answer because you're dealing with distance here. So you want to make sure that you take the absolute value. However, let me just briefly mention what you just said, and then hopefully that would be clear for everyone else. But thank you for your question. I really appreciate. So here's the plane, correct, as you said it. So what was the equation of the plane? 4x minus 6y plus z is equal to 5. So what would be the components of the normal by inspection? Do we know that? What's the component of the normal vector to the plane? Anyone?
Would it be
4, negative 6, 1?
Absolutely, 4, negative 6, 1. You know the coefficients of x and y and z if the equation happens to be in a standard form, which means this form. Remember, any linear equation in 2 or 1 or 3 variables in a space happens to be the equation of a plane. Whether you have all 3 variables in the equation, or 2 of them, or just 1 of them, even if 2 of these guys are not there, you still have a plane. You know, for instance, x is equal to 4, you and I will both know that's still a plane, yes? It just so happens it's perpendicular to the x-axis. at 4, and it's parallel to the what? YZ plane. Anyways, so pick a point on the plane, like let's say point, I don't know, P1. So give me a point on the plane, please.
Z is equal to 5.
How about 0, 0, 5? Would that do it? Because it satisfies the equation. Okay. And I have a point not on the plane, which was 3. Let's call it point Q. Let's call it point P. Q was 3, negative 2, 7. So the question is, do I go PQ or QP? Okay, it doesn't matter because you're going to get a vector either way, but at the end of the day, I'm going to take the dot product and take the absolute value. So if you remember, we could what? Project this onto the what? The normal vector. So this is the shortest distance between what? The point and the line. So this distance is not acceptable because that's not the shortest distance. This is the shortest distance. However, to get that, as you mentioned it correctly, I have to find a scalar projection of PQ over N. In other words, either you go distance is what? Scalar projection of, what was it? PQ onto N, or you could say scalar projection of QP onto N. As a matter of fact, the notation is COMP, PQ subscript N, or COMP QP subscript N. And as you can tell, it doesn't matter. But then you have to kind of know what that is. Do we know how to do this? Yeah? Do you know how to take it from here, or are we okay with this? Do we know how to finish this? I think that's the question.
Yeah, that was my main question.
Sure, sure,
It'd
yeah.
just be the dot product of QP N divided
Well,
by the normal vector.
Right, make sure why is it dot
Right.
product, because this guy is D and this is a right triangle, you know, PQR is a right triangle, so D is equal to what? Magnitude of PQ times what? Cosine of theta. Do you see why it doesn't matter whether it's PQ or QP? Does this relationship kind of clear your question? Do you see out of this relationship why it doesn't matter whether it's PQ or QP?
Yeah, I just wanted to make sure that it worked.
No, I understand. But do you see why from this equation?
Yeah, because it's the magnitude.
Because it's magnitude, correct, right. It's magnitude. So what, it won't matter whether you take QP or PQ because you're dealing with magnitude. See, very good. But anyways, give a denominator of 1, multiply top and bottom by magnitude of 1, n. But the top, all these three factors, the product of those guys is just PQ dotted with n. But remember, there's a possibility this guy might be negative because it's a number. Make sure you put it in absolute value bar. And then, ta-da, here we go. Okay, so on the test, if Thursday, if we have a problem like this, please do not pull any magic formulas, yes? Because I am sure there are formulas out there. The purpose of this problem is to see if you know what is projection. So this is a fantastic exercise for understanding the projection of a vector onto a different vector. Very good. Okay, back to the handout. First page clear? Yeah, is first page clear, folks? So it looks like we have gone, sorry?
16?
16, this guy?
Yeah.
I think we have done just like it in the class, did we not? Remember,
I think the trick was that this one was in kilograms and you have to turn it into, like, in terms of weight.
Right, so the only trick, excellent, because it's a metric system, Now this guy, the gravity is no longer what? The weight of the, what you may call it, the decoration. Now this would be negative mg. So you have to kind of multiply the mass by, notice this is a mass. It's not the force. To convert the mass into force, you got to multiply it by g. That's the only thing which is different than English system. That's all. In English system, the what? The weight is in pounds, so is the force. So no problem. But there is more to it. Behind the scene, those of you who have taken statics, you know, in English system, mass is what? In terms of slug. So what you do is what? Take this and divide it by 32. Then you have to multiply it by g. Let's say this guy is pounds. But g in metric system is also 32 feet per second squared. These guys cancel, and lo and behold, you get the what? Force exactly identical to the mass. But that doesn't work in the metric system. Why? Because the mass is in kilogram, but the force is in what? What's the unit for force? Anyone? I can hear you. Mass is in kilogram. Force is not kilogram. What's the unit for force in metric system? You know it. Just say it. So
Newton?
exactly. Newtons. Newtons. Yes. They are not the same. But in English system, when you take the pounds divided by 32, you get slugs. That's the unit of what? Mass. Multiplied by g, which is 32 feet per second squared, but 32 is canceled, you still get the what? 5 pounds, which is your force. But that doesn't work in metric system. That's the only thing which is different than the one I did. I hope that kind of solves the problem. We good with 16?
Yeah.
Yeah. So, all right. Next page. What is this? 17 through 24.
Can you do question 20, please?
Which one?
Question 20.
20. Wow, you've got all these parts. So that will take like 2 hours. You sure?
Most important, like A through C, because I had problems with those during the homework. I
Yeah.
kept getting the answers
Sure.
wrong.
You got it. So yeah, I was just kidding. It shouldn't take that long, but here we go. So number 20 is good old helix. Okay. And because what? The y component takes the parameter t, so the helix is going to open along the what? Y-axis. So at t0, where are we? 0, 0, 1. We are here. So, so it's going to kind of wrap around the what? Y-axis. Do you see it? So the question is, what is the unit tangent at 0? Remember the definition of unit tangent is what? Is r prime of t divided by its magnitude, correct? So in our case, it will be what? Cosine of t, what are you doing? Taking the derivative minus sine of t over the magnitude. What's the magnitude? That's cosine squared plus 1 squared plus what? Sine squared. But that guy gives you what? Cosine of t, 1 minus sine of t. But cosine squared plus sine squared is 1, so you get square root of 2. However, evaluating this unit tangent at 0, that gives you, what does it give you? 1, 1, 0, there. Is that right? Now, to find normal vector, okay, to the curve at 0, all you have to do is what? Take the derivative of what? Unit tangent, correct? Take the derivative of unit tangent and divide it by its magnitude. That's how it's defined. In other words, this is defined as t prime of t over magnitude of t prime of t. So what is the derivative of this guy? Not the answer here, because you want to take the derivative of this guy, not the one you evaluated, yes? What is it? It's 1 over square root of 2 times negative sine of t, 0, negative cosine of t. What are you doing? I'm taking the derivative of the unit tangent. Then what are you going to do now? Well, I'm going to take what? The magnitude. Well, this guy is just a scalar, pops right out. But the magnitude of this is what? Minus sine square, 0 square, minus cosine square t, correct? These guys nicely cancel. And this guy sine square plus cosine square is 1, so you get 1. So the bottom line is you get minus sine of t, 0 minus cosine of t. So if you evaluate this at 0, you get 0, 0 minus 1. So there goes the normal. Okay, to what? To this helix at 0. So in other words, this is how it should look like. Let me see now. You have 1, 1, so I'm not sure if I did this right, but at 0 we are, where is 0 at? 0, 0, this is 1, right? So we are here. So from here you draw the, what? Pretend you are on the brand new coordinate system. So here is z-axis, here is x, here is y. X, this is y. So where are we? 1, 1, right about 1, 1. So you would be somewhere out here. Perhaps my graph should look like something like this. So it looks like what? This guy is what? Tangent. So that's my unit tangent at 0. Okay, so this is the guy. Normal at that point is -1, so it's right about here. So this is the normal. Okay, and this is just my what? X-axis. This is my y-axis, my z-axis at point what? 0, 0, 1. That's where t is equal to 0. Okay, once you get these two numbers, when it comes to binormal, there is no need what to do any derivatives, or there is no need to take what cross product of t with n in general. Just take the ones which you already evaluated at t equal to 0 and get on with the problem. What does that mean? That means if part C or part, what is it, the G wants me to find the binormal vector, all I have to do is what? Take the cross product of t with n. By the way, the order matters. The order very much matters. So this is I, J, K, correct? And t was 1, 1, 0. And n came up to 0, 0, -1. Is that right? So if I do this, I would get -1, negative, that's -1 positive, and that guy is 0. So that would be the binormal vector, what? Which happens to be perpendicular to what? T and n at that point. So if you just go 1 to the left and 1 over, so I would say this would be my binormal vector at 0. Remember, because by definition is cross product, so that means binormal vector is perpendicular to both what? T, unit tangent, and unit normal. You remember what T and N, what was the significance of T and N, yes? T is in the direction of the motion. N tells you how the curve turns, not bends, but turns. So this is about turning. This is about direction of the what? Motion. Okay, as far as the curvature, I think if I'm not mistaken, I give you guys a formula. Do you guys remember that formula? It had something to the power of 3/2. Do you remember? Does anyone remember? Okay, that doesn't come up in daily life more often, so I don't memorize it. So, if anyone remembers it, please let me know, so I can just give you the formula. So it's R prime cross R what? Double prime over magnitude of R prime what? Cube. There goes your formula right there. Okay, there it is. Yeah, because the definition of curvature is what? How fast the unit tangent changes with respect to arc length. So S here means arc length. Okay, but this is very hard to what? To manipulate in homework assignments. So we have a nice formula, which pretty much, if you manipulate this, this guy pops. As a matter of fact, I have a handout. If you're interested, how this guy becomes this formula, shoot me an email. I'll show you the steps. How to go from definition. This is the definition of curvature, which is, you know, the rate of change of unit tangent with respect to arc length. And of course, it's a number, so it has to be magnitude, right? And what? And this guy. So how do you go from definition to the formula? Shoot me an email. It's like 2 pages. So I'll show you the steps to go from here to here. But this is the one we use.
Hey, Professor.
Sorry. Yes.
I was doing the homework, and when I got it wrong, it showed me for what we're doing right now, the curvature, another form of it, and it's 1 over the magnitude of the velocity times the derivative of the unit tangent vector.
This is the velocity. Can you see it?
Yeah, but it's not squared. I'm saying it's 1 over the absolute value or the magnitude of the velocity vector, just like over 1 times the derivative of the unit tangent.
As a matter of fact, that would be in our textbook. That would be like, yes, you are absolutely right. But the question is, which one is easier to work with, because they both take you to the same destination. So whichever you feel comfortable using, by all means, go ahead. In our textbook is this. Curvature is magnitude of velocity, cross product of velocity and acceleration, over magnitude of velocity, which is speed cubed. Can you see the resemblance? Yeah?
Yeah.
Yeah. First derivative is velocity, second derivative is acceleration, and this guy is magnitude of the velocity, which is what? Speed. So either way is fine. So we're good. So back to the question of 20. Are we okay? Incidentally, rho is what? A radius of curvature, which is reciprocal of what? Curvature. Remember what curvature does. It measures what? The amount of bend. And you remember these guys, don't you? Those are like what? This guy and this guy. Does anyone remember these 2 factors? Let me just zoom in. You remember these? Yeah. No, I don't have the answer yet on the chat. Does anyone remember these? These are scalar, these are numbers. But does anyone remember what they stand for? This
Is it,
is
tangential acceleration and normal acceleration?
no, it's not tangential acceleration, is tangential component of acceleration, meaning if the acceleration is a of t, so this guy is some scalar times unit tangent, plus some other what? Scalar times normal. So we call these components of the acceleration. This guy is tangential component. This guy is what? Normal component, and they both happen to be a number. Okay, so what does that mean? The purpose of that is what? You know it. Remember, we talked about this, that if you had a curve and you were going to draw the what? Acceleration on that curve, remember, you could decompose the acceleration into two components, correct? One in the what? Direction of t, the other one in the direction of n. So this would be like ANN, and this would be like ATT. So those are like components of the acceleration along the tangential and the normal vector. In other words, this is how you decompose the acceleration into its component. Remember, one of the takeaway from last time's story was someone said, hey, would the acceleration ever be zero, even if the what? Velocity or speed is constant? And the answer was not really, because here the speed might be constant in a circular motion, but what happens is this guy might be zero, you know, the tangential component, but the normal component is not zero. It's very much alive, and it points to the what? To the center of the circle, and that's the concept of centripetal force. So even though the speed might be constant, but in 2 or 3 dimension, because the velocity changes its direction and magnitude, acceleration is not zero. Be careful. Okay, that only happens like what? If you have a linear motion, like, you know, pull in a box this way, you know, there's no decomposition. It's like, there it is. It's a scalar. Okay, acceleration is just a scalar derivative of velocity. There's no vector involved. Do you see it? However, in 2 or 3 dimension, notice every time the curve what? Changes the direction. Okay, guess what? That affects the acceleration. Do you see it? In other words, every time the unit tangent changes, acceleration changes. The only time acceleration will be what? Perpendicular to the velocity is if you happen to be on what? A circular motion. Any other time is not perpendicular. Be careful. Do you all see it? Anything else on this page? Yeah, so when you do motion problems, when you do word problems, notice no physics formula, yes? Even though the answer might come up right, but the idea is for you to use what? The knowledge of this class, not what you have learned in other classes. And why is that? Well, because that defeats the purpose of we have to spend a month on vectors, and all of a sudden, all you do is just pull a formula. So why did we go over chapter 12 for? Why did we learn chapter 13? So that defeats the purpose. So it's like it was all for nothing. So therefore, please, on the test, if we have a word problem in terms of chapter 13, no physics formula, yes? Make sure you drive the formulas. In other words, for these problems, you always start from A of t is equal to 0 minus gt and keep going. Take the antiderivative, find the velocity. Impose the initial condition for velocity, find your c. Remember, the c's are going to be vectors. and then take the antiderivative of velocity, get the position, then you would get one more c. And the c's are not constants, they are vectors. Impose the initial condition for position, get your C2, box your answer, and now you are ready to answer the question, whatever it is. So from here, you gotta go all the way to position. After this, then you answer your questions A, B, C. What is the maximum height? How long does it take for the ball to hit the ground? And what is the speed at impact? Stuff like that. The only problem here is you know everything, except you don't know what muzzle speed is. Does anyone know what muzzle speed is?
It's the initial velocity.
Is the initial at the magnitude of initial velocity. It's the magnitude of initial velocity that's missing. So what happens is when you get to the expressing initial velocity, you would have V0 cosine of 60 and V0 sine of 60, and you carry this all the way. So at the end of the day, when you get your position vector, the x component of your position vector, whatever the x component is, this guy right here, would be the range, which is given to you as 24,500. So you would set the x component equal to this, and in your x component, you're gonna have V0 in it. So then that's how you can find the muzzle speed, which, as he said it correctly, is gonna be the magnitude of the initial speed, which you don't know. The one I did in the class, we knew what the initial speed is, but here initial speed is missing. That's okay. The procedure still stays the same, except you will carry this all the way through. Do you see it? Are we okay with this? Any other question, please? Is the exam as long as the worksheet? No, of course not. Are you kidding? Worksheet is like, look, this is what we have learned for the last 3-4 weeks. Do you remember any of these? But the exam will be like what? Pick and choose from these problems, these kind of problems, because you can't possibly finish 24 problems in 2 hours. That's just too many problems, of course. So it will be, I can promise it will be less than 30. Promise. So, of course not. I'm just kidding. So we're good with the handout, folks. Are we okay? Is there any other issue on chapter 12 or 13 you're still not clear? Yes?
I'm just wondering why you plugged in 1 for T on number 18.
1 for T on what? In which
Number
one?
18.
18. Oh, oh. Notice the point is not in terms of T. This is what? X and Y and Z component, isn't it? Correct?
Hello.
So, yeah.
Mami, ¿cómo están?
Bien.
Okay.
Ok, nosotros ya íbamos de regreso, pero el camión de que trae tu papá es de...
Okay, let me just mute everyone. All right. Do you see your X is this and Y is this and Z is this? So because you want to find T, shouldn't you replace what? Set 3T squared plus 1 equal to 4, and what? 4T is equal to 4, and what? E to the T minus 1 equal to 1. Notice from the second equation, isn't T is equal to 1? And also, notice this guy satisfies both of these remaining equations. Do you see it?
Oh.
You see it? So
okay,
if you stick
I feel dumb.
1 here, you get 4. You stick 1 here, you get e to the 0, 1. So that's how I knew T is equal to 1. based on the point. Because you have to just set these guys equal to these components, solve for t. We good? We okay?
Yeah, that answers my question.
Very good. I'm glad it did. Any other question?
I had just a concept question.
Yes, please.
It's kind of just out of curiosity. I was wondering what the dot product represents, meaning like we know how the cross product represents the vector perpendicular to two vectors, but what would be, I guess, the physical equivalent of that for dot product?
There is no geometric interpretation of it, but it's used in problems like work as in K, like finding the energy. When you move an object from point A to B, you need to do a dot product. In other words, there is no geometric interpretation of it. However, basically dot product gives you a scalar, but I can't draw any picture of it because this is like A1, B1, A2, B2, A3, B3, and provided A is equal to A1, A2, A3, and B is equal to, let's say, B1, B2, B3. So yeah, it's a scalar, it's a number. So I really don't know how to do a picture to show you what dot product is, but it's an operation which is used in application problems. And the only thing I can tell you is A dot B is magnitude of A, magnitude of B times cosine of theta. But then again, the question is, what exactly is this finding? Geometrically, I can't tell you what it is finding, but application-wise, I can tell you what it's finding. One of the application is doing the work problem, which is force times displacement. Okay, I think we have seen this in our lectures. So if the force is given to you in terms of direction, and displacement is also given to you in terms of direction, the dot product gives you the work. And also you notice when we find the distance between a point and a plane, did you notice we found what? What was it? Scalar projection, which requires dot product. So to answer your question, which is a very legit question, and thank you for that, unfortunately, it's just a number. Whereas you're right, cross product is a vector which is perpendicular to both, but the dot product is just a number. It doesn't really have any geometric interpretation besides the fact is related to the magnitude of the vectors and the angle between them in this fashion. That's all I can tell you. I can't tell you like it's a number which is associated with A and B. I really can't. All I can tell you, if theta is 0, what happens? What happens if theta is 0? If theta is 0, then this would be what? 1. So what happens is A dot B will be equal to magnitude of A times magnitude of B, which is a number. So that just means the vectors are parallel. However, if theta is 90 degrees, so this guy goes to Neverland, so A dot B is what? Is 0. So notice it's about what we get so we can interpret the answer, not about what does this do. It's like, you give me a number, then I'll tell you what it does. For instance, if you remember A dot B, if it is positive, what? That means the angles happens to be acute. if A dot B is 0, the vectors, that is, happens to be 90 degrees. On the other hand, if A dot B is what? A negative number, then that just means the what? Vectors are what? Obtuse. So that's the only interpretation, geometric interpretation I can tell you about A dot B. Other than that, it just, you know, comes up in application problems. Did that help, or are you satisfied with the answer?
Yeah, that helped. I
I'm
was
so
just curious
sorry.
about it, but
Yeah,
thinking about it as an operation actually
I
helps
know.
the understanding.
It is. They are both operations. You know, dot product and cross product are both operations on vectors, and it's called what? One of them is called scalar product, which is dot product. The other one is called cross product, which is a vector. But exactly what it does, this is the best I can explain. This is what it does to the vectors. Sorry if you are not happy. This is the best I can explain that. Okay, anything else? So we good? I was going to mention 14.1. Are you in the mood of a little 10 minutes lecture, or you had it for today? Are you guys okay with 10 minutes lecture? Just make sure we don't fall behind the schedule, because still is 6:25, so we still got you know, we got
Professor,
like
will we have lecture on Thursday?
No, it's all it's 2 hours of what exam. You just take the exam and have a fantastic weekend, and I'll see you all the following Tuesday. There is no lecture, no class. What you do, 5 minutes before 5 o'clock, log on to Blackboard, wait for exactly 5 o'clock, maybe 4:55, and then log on, access the what? Exam on, of course, you know, under the, what was it? Midterm exams, I think. I have a menu on the left side, and print it, start working on it. But whatever you do, make sure you turn your exam before 7 o'clock. Yeah, because at 7 o'clock, then the Blackboard will not accept any late submission. So please make sure you submit your work, upload it before 7, like start uploading like 10 minutes to 7, so you will meet the deadline. Any other question? Let me just show you something quick, and then we can wish it. I wish you guys good luck, and then we can. So I won't see you, but anyways, is there any reason for me to be on Zoom while you're taking the exam? I mean, do you think you might need me live in case you have a question or something? If you do, how about we make this deal? How about immediately send me an email or something? How is that? So I will be next to my monitor for 2 hours straight and wait in case something unexpected comes up or you had a major question. I will be next to my laptop and make sure that I answer any question it might come up. How is that? Or would you prefer me to be in Zoom meeting? I mean, what do you think? Send me email or what? Have a live Zoom. So just like we have lectures, except I won't talk or anything. I'll just listen to see if anyone has any question. I don't know. It's up to you guys. I don't want you to think that I'm monitoring you, so that's not the point. I'm just letting you know I will be available during the test in case something unexpected come up, Or you might say, hey, I'm reading this problem number 5. I don't get it, or something like that. I can't tell you the solution, but at least I will explain what the problem wants you to do. Would that be okay? Yeah, email is good. All right. So in chapter 14, let me just for 5-10 minutes of your time, I'm not going to do anything. I'm just going to set the scene for next Tuesday. In chapter 14, as you can tell, we're going to talk about functions of several variables. All right. So this is where multivariable functions calculus begins. So chapter 12 and 13 was kind of like prerequisite for this chapter. So now that we know a little bit about vectors and a little bit about how to handle some of the operations, so now we are ready to talk about functions of several variables. In real life, the temperature might be a function of several variables. For instance, suppose you have an object in a space and you want to find the temperature of that object. So the temperature depends on the location of the object in the space or even on the floor. So notice functions of several variables, they are surrounding us in real life. For instance, the volume of a cone is a function of radius and height. So therefore we say V of RH, that means volume is a function of radius and h equals 1/3 pi r squared h. In business field, they have this Cobb-Douglas function, which is P of L comma K. That means the independent variables are what? What you see inside the parentheses, these are called independent variables. And what you see as a letter, that's called dependent variables. So in general, this is known as function of two variables, because we have two independent variables, but the volume depends on these variables. So this is a function of two variables. This guy is a function of two variables. This guy is a function of two variables, which is known as Cobb-Douglas production function. All right, and business majors, they use this on a daily basis. P stands for production, L is the labor, and K is the capital. And this is function of several variables. Okay, the next example is the wind chill index. Okay, this is the actual temperature. This is the speed of the wind. Notice we have a function of two variables. Sometimes we have function of three variables. Do you see it? So the only problem is, even though the mathematics extends beyond function of two variables, but geometry doesn't go that far. In other words, I can draw a picture for this guy, which is a surface in space. I cannot draw a picture for this because this is 4-dimension, right? Because you got X and Y and Z, and then you got dependent variable W. So geometry doesn't extend that far. So what is the definition of function of two variables? Is a mapping. You know what mapping is. Mapping means it's a rule that what? Assigns to each order pair in the domain, D is the domain, a unique and one-of-a-kind number on a number line, which is known as f of xy, which is the nickname for z. So remember, when you have z, that's also denoted in function of several variables as a function of xy. So either you use fxy or just simply z, it means the same thing. So what does that mean? So what's the definition of function of two variables? It means any order pair you pick on the floor, remember this is your xy plane, by definition, what? That corresponds to a real number on a what? Number line, which is known as your z value. In other words, the domain is what? Order pair, but the range is a real number, correct? However, for this guy, domain is what? Is all set of triple, order triple in a space, but the range is still is a real number. Do you see it? So for function of two variables, the domain is an order pair, but the range is a real number. So every time you what? Do this is called a mapping. Mapping means assigning. So when you assign an order pair to a what? A real number on a number line, that's the definition of function of two variables. Do you see it? So mapping means a rule of correspondence. Correspondence, it's called mapping. Okay, right? So if that's the case, then we have these functions. Let's say we have f of x, y is equal to natural log of xy plus 2. Okay, question, what is f of 1, 1? Okay, that means when x is 1, y is 1, what is this guy equal to? Well, that would be the same as what? 1 times 1 is 1, 1 plus 2 is what? Is kind of like 3. So therefore the answer is natural log of 3. So notice I took an order pair and I what? Substitute for x and y, and lo and behold, I got what? The real number, which is the value of z. In other words, we call, what? Sometimes you say f of 1, 1 is natural log of 3. Sometimes you say f of xy evaluated at 1, 1 is equal to natural log of 3. So those are the notations we use. And then it goes f of e comma 1, that means replace the x with e, y with 1, and see what the answer is. So notice for every order pair, I'm coming up with a real number. So that's exactly the definition of what? Function of two variables. So how do you find the domain? Well, if you remember the domain of single variables, you had to show it on a number line. For instance, what is the domain of natural log of x? The domain, which is denoted by capital D, domain, is what? Is all real numbers such that x is greater than 0. So on a number line, you go above 0, you put an open dot and draw the arrow to the right. However, for function of several variables, you are not on a number line. You are on xy plane now. For instance, what would be the domain of what? Of say, this should be z for some reason. I don't know how y got in there. That should be z, correct? The question is, if z is equal to natural log of x minus 1, could you please, what? Find the domain. So you are no longer on the number line, are you? So the domain now, instead of just x, is an order pair, such that, what? Because this is natural log, so the logorand, that's what this guy is called, logorand, has to be positive. Okay, so what does that mean? That means any order pair such that x is greater than 1 will do the job for the domain of this function. Do you see it? But sometimes that would be like part A followed by part B, and that would be like, hey, can you graph the domain, please? Okay, the domain of what? F of xy. How would you graph the domain? How would you graph this? Well, you go on the x and y axis, correct? What is the graph of y equals x? Does anyone know? It is what? Straight line, 45 degrees, and it goes through the what? Origin. Remember in algebra classes, when there was no equal sign, so it had to be a dotted line, remember? Meaning, I'm not allowed to take any point on the line. So the points have to be selected off the line, not on the line. So, question, how would I know which portion of the line I should select my order pairs? Should I select my order pairs on top of the dotted line, or should I select it at the bottom? because obviously I cannot select any ordered pair on the dot because this says x is strictly greater than y, not equal. So that's why I have dotted line. Do you see it? Does anyone remember from algebra classes, how did we go about deciding which part of the line should be shaded? Remember, you thought you'll never see that, did you? Well, here it is. It's coming back. Remember, we had to decide whether we should shade the top of the line or the bottom of the line. Do you remember?
X is greater than y, closer to the x-axis.
Correct. So, or when you say x is greater than y, so that's like y is less than x. So that means you have to what? Shade the bottom. Remember, the shading is not to improve our graphing skills. That just means what? Any order pair you select in this vicinity will satisfy as being what? The domain of the function. So that's what this shading is all about. The shading is any order pair you select here, 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 will do the job for the domain. So you got infinite many answers, but you got to make sure the order pair you select, they come from here. One other things you could have said that this is what? The region you have to shade. Why don't you pick a point, like let's say right about here, not on the line, but offline. Let's say we call this a test point. Let's say this is 2, 0. So I'm gonna call T20 a test point, you know, just like algebra classes. But I could just tell by the direction it's less than. But anyways, test this. Where would you test this? Right here. Okay, what was my x? 2. Is 2 greater than 0? Yes, true. So we always shade the true side. So this would be a follow-up for domain problems. Sometimes the domain might be what? Might be a surface. So let me just do this guy and we should be okay. How about w is equal to natural log of x squared, what? Plus y squared plus c squared minus 4. What would be the domain? The domain here is not order pairs, but it's order triples, such that x squared plus y squared plus c squared minus 4 is strictly greater than 0. So now the follow-up question is, can you graph the domain now? So now I'm in 3-dimensional space, no? I'm in the space, I'm in space. There it is. Does anyone recognize the picture of that guy? Remember, I can manipulate it and write it as x squared plus y squared plus z squared is greater than 4. Does anyone recognize this? Yes. Here's the z-axis, here's the y, here's x. What is the graph of the domain?
Everything outside the sphere with radius 2.
Everything. Excellent. Thank you so much. I really appreciate it. Everything outside of the sphere whose center is at what? 0, 0. But what? Radius is 2. And you are not on the sphere. You are outside the sphere, as the gentleman mentioned. So you shade outside of the sphere. By the way, this right here is called boundary of the sphere. So you are not on the boundary of the surface. You are off the boundary. So boundary means what? Including the edges. In this case, including what? The sphere. But we are not. It's greater. Because it's greater, so what? Any order pair you select outside of this sphere with radius 2 will do the job. All right, so this is not it. There's more to it, but I thought I'd give you a heads up what's coming up in chapter 14. You know what we're gonna do, don't you? we're gonna take what? Derivative of these multivariable functions. We're gonna find the equation of a tangent plane. We're gonna find maximum minimum problems. Those are called optimization problems. So that's where we headed with chapter 14, guys. Hey, I wish everyone good luck and hope you all do a fantastic job on Thursday's test. And it's gonna be piece of cake for those of you who know have done your homework. You'll be done before its time expires. So I'm sure you will all get a high score on the test. So with that, have a good night, guys. Take care of yourself. And I wish everyone good luck. Take care.
Thank you, Professor.
Bye. Good night.
Thanks, Professor.
Bye, guys.